Hey everybody, it's Keith with the L1 Automotive Training Channel, and today we have a 16 F-150 that has a goofy network concern. And we get a lot of these trucks, and I'll kind of show you how these ones typically go. A little anticlimactic because it became one of the common issues that we see. So the vehicle came in with a complaint of the front display control interface module is non-responsive, but it's non-responsive all the time. So we believe that to be a separate concern. It also has some issues with HVAC, heater controls or Inop, along with other things on the medium speed bus that we notice don't function when the issue occurs, and it's intermittent. And this seems to be a reoccurring theme with this body style of truck when we have these types of concerns. So our first puzzle here is we've got to go in and pull a pre-scan. Looking at all the DTCs, not going to kind of go through everything, but you notice all the U codes. What we find is that the vast majority of the DTCs on these vehicles have a medium speed control bus or high speed bus off message, or like a lot of DTCs where the accessory protocol interface module has no communication with the body controller. And when you look at the topology of these trucks, the accessory protocol interface module, the APIM or sync module sometimes, and the body control module are on both are on high speed and medium speed. Both offer the terminating resistors for either sides of the network. So there's a couple like known issues we run into on these trucks. There's a splice connector like I don't remember, like 1041 or something down here that gets moisture in it and causes a lot of weird medium speed issues, but this one didn't fit with that. This one fit with more of the BLIS alert comes on first, and anytime we see that, we immediately go to taillights, because the blind spot indicator system, the BLIS system on these trucks is on the medium speed network. Also, these taillights are fairly common for getting moisture intrusion, and that's what we found on this one. So let me show you. So we have the taillight out. We noticed that externally we could see a bit of moisture and moisture intrusion on it. You can kind of see some water droplets inside the housing there. Inside of the housing is the radar unit. This is the actual BLIS unit inside of it. It is a radar. It uses radio waves and time of flight technology to output a radio wave, and based on the time it takes for that wave signature to come back and the intensity, it's able to determine how far away objects are in the blind spot area of the truck. That's one of the advanced driver assistance systems on these trucks that are available. So it is mounted inside the taillight assembly. Now, as you can see in this one, I think we already kind of got a lot of it out of there during our initial testing, but I'll put some pictures in there. Right here where we had a bit of water, and as you can see just here in the video, there's still quite a bit of water inside of here, a lot of moisture inside the connector, some green crusties, some moisture intrusion in that plug wicking through this harness. Now, had we had seen more moisture in this harness, we would be concerned that most likely it would be that junction connector. I think it's 1041, I'm not sure. We'll have to double check that later. But once we see moisture in this harness or in this taillight, we kind of got to go with the customer, let them know, hey, this is on the medium speed network. We're going to need to fix this issue first and then see if it continues on. Also, another piece of evidence that was noted is the customer said when it rains or when they go through a car wash, it happens more often. So we immediately kind of recognized that it's probably something moisture related. So that's a big part of our diagnostic process. Now, in a typical successful diagnostic process, there's a couple steps. I apologize, I'm trying to hold the camera up, but I had shoulder surgery a couple weeks ago, and it's a little hard. I don't quite have full range of motion yet. I will tell you, if you get shoulder surgery, it is horrendous. So a typical diagnostic process would be something like confirming the customer's concern, and then doing an initial analysis of the vehicle, which may be pulling technical service bulletins, recalls, service bulletins, preliminary information reports, star cases, any other kind of documentation that addresses some common concerns. Then we want to go ahead and pull some initial analysis from the vehicle, like a pre-scan, and look through all the DTCs to start building an idea of what symptoms fit into what system so we can determine which direction to go with our testing. Once we have that information, we can build our test plan. And our test plan is going to be executed many different ways depending upon what type of concern. Everything from a noise or a sound to a concern like this where components inside the car intermittently don't work are all going to have a different test plan based on the symptom we have and the system it's associated with and how the system design and architecture is made. So we're going to build a test plan and then execute that test plan, following up with really good documentation to come to our root cause analysis. We want to know if the concern is due to a part failure, and if so, is this part going to fail again? For instance, we could clean out this taillight housing and solve this customer's issue, but did we get to the root cause of the concern? No, the taillight is allowing water to intrude, so we're going to need to get that in there. We actually do have a taillight for one of these in stock because it happens. This particular one happens to be off of a truck that got totaled that I owned, so I know that it's a good one. It got totaled for a totally different reason, so we're going to sell this at a heavily discounted price. I typically would never offer a used part, but this is one that I know works. It doesn't have the module in it, so all the customers' modules have to move over. So our root cause analysis is going to come down to water intrusion. Now, we also don't know if there are other concerns with this vehicle, so we're going to have to present that to the client that, hey, this is what we found so far, and this is what we need to do, and then retest when we're done. That way we have a proper analysis and testing procedure, plan, outline, and everyone is fully aware of what's possible. So, hope you like the explanation of what's going on and how we typically would do an analysis. And don't forget to hit the like and subscribe and the little bell icon and notification. All that stuff helps you keep up with what's going on here at the shop.